Welcome to solverfy.
Right, for our first compound, we have a pretty complex ring structure there. But if we were just looking at our functional groups, what we see is that we have OH attached up top, and OH is an alcohol. We see some CH3s there. Those are just methyl groups, so those are carbon chains, so we're not as focused on those when we talk about functional groups. And then we also have a ketone. Right, so a ketone is a double bonded oxygen, and that is attached to a carbon. Okay, notice there are no other oxygens around it. If we change the number of oxygens involved, or if we didn't have just carbon attached, that would change the functional group. Right. On the next one, we have another alcohol. Right, so OH is always an alcohol. This time we also have another oxygen involved. So up on the top, we see a CH3O attached to the ring. Okay. So that CH3O implies that it's just single bonds because the carbon has 3 other hydrogens attached to it. So anytime that there is a single bonded oxygen in between 2 carbons, it's an ether. E-T-H-E-R. Right? On the right-hand side, we also have carbon double bonded to oxygen and a single bond to a hydrogen, okay, with carbon, the chain on the other side. Anytime you have that terminal double bonded O, it's an aldehyde. Right? So you got to watch that. You got to determine if it's attached to a carbon, just carbons, or if there is a hydrogen there, if it's a terminal end substance. Right. The big one that's last, we have quite a few functional groups here. Okay. So we see some new things. We see H2N attached to a carbon. Okay, that's a classic NH2, NH3 compound. That's called an amine when it has a nitrogen there. Right. Inside, we also see we have a carbon double bonded to an oxygen, but it's important to note that there's a nitrogen also involved. Okay, so there are a lot of double bonded oxygen options. So when there's a nitrogen involved, we call it an amide. So it's a little bit different than an amine, right? Because it does have that oxygen as well. Right, up on the top, we have carbon double bonded to oxygen, single bonded to oxygen as well, right? With carbon on either side of that whole complex. And that is an ester. And then finally, down on the bottom, we have a carbon double bonded to an oxygen with an OH. Remember that OH with a double bonded oxygen is a carboxylic acid.